Yo, what's going on? How's the life, gang? Welcome back. Seeing some familiar faces. Yo, Angel, Amina, Rayhan, what you seeing? Annie, Miss Biology. Hope you're doing good, man. You can watch it back, though. It's all good. He's here. What you saying? Mazza, BC, Cameron, Chloe, Asha, what you saying, Brev? Hey, yo, Halima, you coming to all my sessions? Nice one, mate. Love to see it. Aaron, what's up? Abdul, what you saying? Kira, what's up? Monkey Pickle Pants. What's up? You need the mass. It's all good, dude. So what? Favor, what's up? Last lesson I taught you guys factorizing. Wait, was it factorizing? I think it was factorizing, right? I showed you guys the oi oi method. How we factorize things in the best and most efficient way possible. So hopefully you guys have practiced, innit? Yo, Kat. Rondo, what's up? Esther. Rajan, what's up? Katya, welcome back, dude. You hate Surds, BC. Don't worry, we'll change that, innit? Oi, oi. Delight. So yeah, after last lesson, I showed you guys that factorizing does not need to be that difficult. This lesson, I'll show you guys that surds also do not need to be that difficult. The thing about surds, right, is at A levels, you have access to a calculator, right? But, ayo. Oh my god. I miss you guys too. But even at A levels, guys, you can't just rely solely on the calculator. You need to show you're working, yeah? So with surds, you can't just type things in the calculator and expect to just write down the answer, yeah? So, if you're new here, let me just quickly introduce myself. What's going on? My name is Neil Trivedi, fully qualified maths teacher, over 8 years of teaching experience. I did a maths degree at UCL, and I did very well. And my students do very well in their exams as well. So it's my job to turn you guys into maths geniuses as well. Yeah, that's my job. So, let's get to it, mate. Rationalizing denominators. So surds really is all about rationalizing denominators, right? Are you going to teach a new method and call it the yo-yo-yo method? What's that good to... What's the yo... Oh, wait, no, that's what I say. Yo-yo. We'll find something. Damife, what's up? Katya, it's not looking good, Briv. So we know that root A times root A is A. So, for example, what do I mean by that? Guys, root 2 times root 2 is equal to what? And I'll prove it to you as well. This workbook is short. I can't lie. Maybe. We'll see how we go. 2. Good. Now, just remind me, guys. When you multiply two numbers with the same base, what do you do to the powers? So when you multiply two numbers with the same base, what do you do to the powers? Devin, good. Annie, good. Dara, good. You add them, yeah? So root means 2 to the power of a half. So what we're basically showing here, yeah, is when you add those powers, you get a half plus a half, which is just 1, which is 2, yeah? So root of anything times by itself, the root just goes. Yo, Gabriel, my guy, welcome back. And we know squaring, yeah, is the opposite of rooting. Yeah, so this just goes. Okay. Now, we have to deal with situations where the root is in the denominator. So, in general, guys, we do not like irrational numbers in denominators. Do any of you guys know what an irrational number even means? Trust me, BC. You have to understand how things work, and then the maths becomes so much easier. Yo, Ninja. Hope you're doing good, man. Still cussing me out as usual, yeah? Hopefully not. So how many of you guys know what an irrational number even mean? What even recurring decimal? So a recurring decimal is a rational number. I'll explain why in a second. Annie, a over b. So you're right. So a over b is a fraction, right? So guys, an irrational number, good, has a back. I don't know how to say that name, but it's just like looks like random letters. So a irrational number cannot be represented as a fraction where the numerator and denominator are whole numbers. So for example, you guys were talking about recurring decimals. What is this number as a fraction? What is that number as a fraction? What is that number as a fraction? Taj, yeah, 1/3. Yeah. So that means it's a rational number because it can be represented as a fraction. Yeah. The numerator is a whole number and the denominator is also a whole number. Whereas pi cannot be represented as a fraction. Yeah, you might say pi over 1, but pi is not a whole number, right? So that doesn't count. So root 5 is what we call an irrational number. It's an irrational number because root 5 cannot be represented as a fraction where the numerator and denominator are whole numbers. So what we're going to do is we're going to employ a tactic like we did right at the beginning over here to rationalize it, to turn it into a whole number. Yeah. So with fractions, we can do some scaling here to what we call rationalize the denominator. What do you have to multiply root 5 by to turn it into a whole number? So what do you need to multiply root 5 by? Ramesa, good. Angel, yeah. Good. Good, guys. So we times it by itself, essentially, yeah? We're going to do root 5 times root 5. But we know that we can't just times the denominator by root 5, right? So we have to times the numerator by root 5. Okay, guys, in the denominator, root 5 times root 5 is equal to what? The numerator is just 1 times root 5. It's just root 5, right? So the denominator, though. Nice. So, guys, root 5 times root 5, you're squaring it, right? So you just get 5 in the denominator. Good stuff. Good stuff. All right, part B. What are we going to times top and bottom by? What are we times in top and bottom by? Yo. Root 7. Okay, good. Now, without doing anything, can you guys tell me what the fraction would look like? When you times top and bottom by root 7, what does this all simplify to? There's 2 steps to this. Without the final answer, just this step. Just this step, like what Halima's written. So some of you guys could be cheating, putting your in a calculator. Coin, good. Cameron, good. Ishan, good. So the denominator, we know we have root 7 times root 7 is just 7. And on the numerator, you have 14 root 7. Yeah, then what do you notice? Jazz, good. So now is where we notice something. Okay, good. Now we notice we can simplify the fraction. Fraction. 14 over 7 is dos. Dos. Root 7, mate. Nice one. Okay. Part C. What are you guys thinking about part C? CFK, you have to show you're working still. Yeah, that's the thing. You have to show you're working. Annie, I see you. Arcel, I see you. Delisha, 2. What, are you saying that's the final answer? So, guys, I need working out. Aaron, good. So, guys, we're not typing things in the calculator, yeah? So, like what Queen's saying, we can rationalize by timesing the top and bottom by root 5. Now, there's 2 ways you can do this, guys. You can times top and bottom by root 5, or you can notice that we can simplify one of the surds first, yeah? And You'll get the answer just as quickly doing either one of them, yeah? But I just want to double check that you guys remember how to simplify surds. How would you simplify root 20? How do you simplify root 20? Halima, I see you. Well, we are doing that, Natalie. We are doing that. Okay, good. So we first split this, guys, as 20 being 4 times 5. So remember, whenever we simplify surds, we always do it to introduce square numbers, right? So 4 times 5. Then you're rooting the 4, 2, and then you're rooting the 5, isn't it? Over root 5. And then what do you notice happens once you've done that? Cancellation. The root, because it's all times and divide, right? So the root 5s just cancel and we're left with nos. Nice. Yeah? Yes, mate. And this is how we simplify surds. Yeah? Just makes 2, mate. Next one. Simplify by rationalizing. Okay, so for part A, what are we going to do? What are you guys thinking? So we have 2 plus root 2 over root 2. Times both times by root 2. Now, there's something I would tell you guys to do here. What is it? Kind of mentioned it last time. Yes, Neha. Bracket. Protect. Guys, you should always be protecting places where there's a plus, which avoids us from cancelling, yeah? So we have to be very careful, guys. These do not cancel because there's a plus on the numerator, yeah? So we must protect by using a bracket. And then we are going to times the top and bottom by root 2. Okay? Now, on the numerator, if you ever have a surd on the outside like this, you need to expand it. If it was just the number 2, I would tell you guys, just leave it on the outside because things may cancel after. Yeah? So, because it's a surd, you need to expand the bracket. So guys, can you expand the bracket? Just that bit. Can you tell me what you get when you expand that? What do you get when you expand that? Monkey, I see you. Aaron, 2 root 2 plus 2. And I'm seeing a lot of the same. Zainab, Angel, 2 root 2 plus... Angel, you would have had root 4 there. So you could say 2 root 2 plus root 4. Yeah, that's fine. Or we could remember that root 2 times root 2 is just 2, right? Okay. So the first one, root 2 times 2, they're different types of numbers. So you're just going to get 2 root 2, nothing simplifies there, plus. Root 2 times root 2, remember they're the exact same. So it just becomes 2. Divided by. Then we all know root 2 times root 2 is 2. Is that our final answer? We were happy with that, mate. No. We should be aware that every single term, right, is divisible by 2. Yeah? I mean, you could factorize out 2 for sure. Or you could say, look, let's just divide everything by 2. You're dividing every single term by 2. What is that? And in the denominator, you just get 1. So you don't even need to introduce anymore. So 2 root 2 divided by 2 is just root 2. You have 2 of them, and you divide them by 2. You just have one of them, you're just halving the number. Root 2 plus 1. Yeah? Alright, part B. What are you guys saying for part B? Root 2 plus root 18. Annie, how do you type so fast? Annie, you okay? How's this possible? So, Ramesa, times by root 12. Is there something we could do first? We can't divide by 2 because they are all being protected by the root. So, we want to make our lives a bit easier. Annie, no. Good to Lima. Simplify. Yeah, we can start simplifying our expressions first. So guys, root 18. How are we going to rewrite root 18? And then, yes, Amina, we might need to use brackets after. Ishan, Neha, all getting the same. So remember, when we simplify, we need to find square numbers. So 18, I'm going to say is 9 times dos. Yeah, what about root 12, guys? Actually, didn't we? No, we did root 20. What about root 12? How are we going to simplify that one? So that would become 3 root 2 on the top. That is correct. 3 and 4. Yeah. Looking good, mate. It's looking good. So we have 4 times tres. Alrighty then. So you have root 2 plus 3 root 2 over 2 root 3. Alright. What do you notice? What do you notice, mate? Three and 4. What does that mean? Taj, good. Zainab, good. So on the numerator, yes, Amina, good. So you have root 2 plus 3 root 2 there. They're like terms, exactly. So they add to make 4 root 2 over 2 root 3. Anything else we could potentially do here before? Because obviously root 3 is in the denominator. Is anything else we can perhaps do first? Anything we could do first, perhaps? Annie, good. Divide by 2. Amina, good. So the 4 and the 2, guys. And then Rhonda, we will rationalize, yep. So 2 goes into 4 twice, yeah? So we could write it nicely. This is set us up nicely. Okay, now what are we doing? So basically the whole time we've just been simplifying. We haven't even got to like the main point of the question. The rationalization and that. Okay, now we times top and bottom by root 3. Can you guys times top and bottom by root 3 and tell me what answer you get? Times top and bottom by root tres. Ishan got 2 root 6 over 3. Taj, don't forget denominator. Abdul coming in with the fraction syntax and that. Okay. Demife, where's the 4 coming from? You have 1 root 2 plus 3 root 2 to give you 4 root 2. Yeah. Okay, now in the denominator, guys, you just have root 3 times root 3 is 3. Then you have 2. And then here we have root 2 times root 3. They are the same type of number. So you just multiply within the roots. Yes, there you get root 6. Okay, nice. Part C, guys. What are we going to do first? Okay, simplify. Simplify the individuals. So we've done root 18 already. That was 3 root 2. Can you guys simplify root 8? The root 18, I'm just going to change it. Root 18 we did was 3 root 2. ¿Qué pasa? 2 root 2, is it? So yeah, 4 times 2. So you got root. Make sure you show this working. 4 times 2 plus 3 root 2. That definitely does give you the 2 root 2 plus 3 root 2. What about root 50? How are we rewriting root 50? Five root 2, is it? Yeah, nice, because 50, sometimes it helps as well, guys, if you want to write down your square numbers. Yeah, for a Surds question, sometimes it helps to just have the square numbers on top. So 50, you can rewrite as 25 times 2, which does give you 5 root 2. Okay, then what? Aha. Interesting. Very interesante. Very interesante. The top. Yes, we add the numerator. And this is why, guys, you should not go straight into just rationalizing denominators. Because here I'm showing you that by simplifying, yeah, you get a much nicer solution without even having to do much work, innit? Work. 1. Uno más. Work on my Spanish. Español and that. My Spanish is great. Dzień dobry. Alright, next slide. Is it possible without simplifying? Yeah, BC, you just times some by root 50. That's quite long. Yeah, you'd be working with some big numbers. Trust me. So, why were the last questions light? I don't know, man. Calories in versus calories out, innit? So, rationalizing denominators. Sometimes we will have more than one term in the denominator. When this happens, we need to use the difference of two squares principle to rationalize the denominator. Dots and that. Remember, x squared minus y squared is x plus y, x minus y. Just to recap what we did last lesson, guys. What would x squared minus 25 factorize to give you? Dzień dobry. Opposite signs. Exactly. Calories in, calories out. Ishan, I see you. Taj. Amina, nice. I see some of you been doing your homework and that. X plus 5. X minus 5. Let's do one that you guys found a bit difficult last time. What about 16 minus 49x squared? Dzień dobry. Let's get this one down. What is that going to look like? Then it's not looking good, Aria. Goodness. Basically, you just forgot your x. Ishan. Yeah. Ishan, why do you never put a bracket around your first set of terms? Okay. Nice. So here, guys, remember the number is first. So we didn't do 4 and 4. Then for 49, x squared, we have 7x. 1 plus, 1 minus. Nice. Yeah. Now, this principle applies to something like this. Because if you remember, guys, from GCSE or even Key Stage 3, it's not possible to just times by root 5. Because if you times by root 5, yes, that becomes 5. But then this becomes 1 root 5. So you don't rationalize it. You still keep the root in the denominator. Ideally, what we want is to square this. But then at the same time, we'll have to square this using the difference of two squares principle. Yeah. So we just multiply by the exact same thing. We multiply by the exact same thing. It's just 1 is the opposite sign. Yeah. We have to do it to the top and the bottom, right? On the numerator, it just is what it is. Now the denominator, when you expand that, guys, what does that simplify to give you? What does the denominator simplify to give you? Natalie went with 4. Ishan 4 as well. And I'll show you guys the only piece of working you need to show here. Now, okay, you're all going with 4. So, the whole point of the difference of two squares principle is that there's no middle term. Look at the top here, guys. There's no middle term. There's no xy term because they always cancel. So like what Ishan said, you're squaring the first term minus squaring the second term. So all you're doing is you're doing root 5 times root 5, which is 5. Then minus difference of two squares. 1 times 1. Like that. Yeah? So there you go. It's done. Root 5 plus 1 over quattro. Nice one. Dive. Alright. Part B. What are we going to times top and bottom by? 2 over root 6 plus 1. What are we times in top and bottom by? Bro said conjugate. That's wild. A little further mathematician out here. Root 6 minus 1. Nice. So the same thing. Remember the brackets. Alright. What does the denominator multiply to give you? Mimo, why? Did you get it all wrong? Why not, Amina? Favor, Annie, Angel, Goodness, all getting the same answer. Nice. Okay, so nice. Dara showing the working out as well. So we have root 6 times root 6. So you only need to show this bit. Root 6 times root 6 is 6. Minus uno times uno is uno. Now, on the numerator, should you expand the bracket? Yay or nay? In general, what would I recommend you do in this case? Would I recommend you expand the bracket or not? Nay has said nay. Nay, nay. Leave it. Okay, good. So what I recommended to you guys is if this number on the outside is a surd, you need to expand it. If it's an integer, yeah, like 2 is, even if it was negative, just leave it. Yeah? So we have 2 lots of root 6 minus 1. Yeah, because sometimes it might simplify even more. And even if it doesn't, like now, it's okay. This answer is fine. Yeah? Nice one, Dive. All right, part C, mate. What are we multiplying top and bottom by? Root 7 plus 1. Root 7 minus 1. Okay, nice. The exact same thing as the denominator. But changing the sign, might. Change the sign. And as you know, on the numerator, we need to protect. Can you guys expand the denominator? Just the denominator. ¿Qué pasa? Favor went with 6. Catty as well. Remember, guys, it's a minus. So you're subtracting. So you're doing root 7 times root 7 is 7, 7. Minus 1 times 1 is 1. Yeah? Can you guys expand the numerator? What do you get when you expand the numerator? You could give me the individual terms as well if you want. Hey, no cheating though. I'm seeing 8 plus 2 root 7. 8 plus 2 root 7. So we have root 7 plus 1 squared. And you're multiplying by the same thing. Nice, Angel and Aaron with the working out. And Rhonda. Good. So here, the kind of trick here, guys, is you square the root 7. Is just 7. Yeah. Then you multiply these together is root 7. You double it. So 2 root 7. Then you just square the last number. Uno. Okay, so we have 8. 2 root 7 over 6. Now what? Now what, mate? Good. Simplify. We can divide every single term by dos. Divide it by dos. So we've got quattro. These just go. Root 7 over tres. Nice. Always drinking the tuna smoothie. Got to keep your brains working. Alright? It's not that bad, is it? It's not that bad, is it? Is it now? Is it wicked? Let's get some harder ones. Even though we have access to a calculator all the time, we must still show our working. Alright, so in this case, what are we timesing top and bottom by? What are you saying here, mate? Brother. What's that? The same thing, just with the plus. Alright. Let's put it here. Now, without simplifying fully, can you guys tell me what the denominator goes to? I want you to tell me number, minus number. Can you tell me what those two numbers would be? Annie, so 3 root 2 is already simplified, right? Because the root 2 can't be simplified further. So Ishan, Aaron getting the same. Ayo, Ishan, did you say 18 minus 1 is 7? This guy, boogin. Ramesa got the 18 minus 1 as well. Katya. Put as root 18. No, because then you'd have to simplify it anyway, right? So keep it like this. In its most simplified form is definitely the best. So here, guys, we've got 3 root 2 times 3 root 2. Now let's remind ourselves how we multiply these two numbers together. So first, well, you're going to multiply the numbers which have the same properties. So 3 and 3. 3 times 3 is 9. Multiplied, then we have root 2 and root 2. So you multiply those numbers, which is 2. And that 9 times 2 does give you 18. Yeah? Then finally you have minus 1 times 1 is 1. So that's how I would write it. Yeah, so it is 18 minus 1. You guys are correct. Now on the numerator, do we expand? Do we expand? How have you run out of space already? Now that don't make sense. Make it make sense. No. Yeah, guys, it's a 3 on the outside. It's looking good. We like a 3 on the outside. No problems. So we have 3 root 2 plus 1 over 17. Nice. There we go, mate. There we go. So, on the denominator, guys, we are timesing by 2 root 5 minus 2, innit? Can you guys expand the denominator for me? You can, Mabina. It wouldn't be incorrect there. But you don't need to. It's just extra working. So with the full working, like... okay, Ramesa, you did put in there. Katya as well. Even though she somehow run out of space. Make it make sense. 20 Dara as well. Angel. Well, actually, Angel, if you're Spanish, that would actually be Angel. That could be your name. Angel. How are you doing, Angel? So I'm seeing a lot of 16. So we're going to do this times this. 2 times 2 is cuatro. Times. Claro que sí. Angel. Root 5 times root 5 is 5. Minus 2 times 2. Cuatro. Angel Di Maria. Exactly. Alright, can you guys expand the numerator? Ideally, I want you to show me the different terms, the 4 different terms you're going to get when you expand. Angel. Hasta luego. ¿Qué pasa? Ishan 20 minus 4 root 5 minus 2 root 5 plus 2. Favor, did you miss some terms? Aaron got the same. Jazz coming with the nice fonts and that. Alright. Let's see. Well, the first 2 terms are the same as what we had before, right? The 2 root 5 times 2 root 5 is the same as the denominator. That's the 4 times 5. Then 2 root 5 times minus 2. The 2 root 5. Same way. Room pace. Oficial. Minus 1 root 5. Should it be 2 root 5? 2 root 5 times minus 2 is minus 4 root 5. You're all getting that. Nice. The dot in between just means multiply. You can either write the multiply sign or the dot. So we have minus 1 times 2 root 5, which is just minus 2 root 5. And then, have you guys ever watched the film Dude, Where's My Car? It's so funny. You guys are Utes, innit? You ain't seen these classic films. Still watching Peppa Pig and that. Minus 1 times minus 2 is plus 2. Alright, cool. 20 plus 2 is 22. And then minus 4 root 5 minus 2 root 5 minus 6 root 5 over 20 minus 4, 16. Alright, now what? Dude, Where's My Car? It's such a legendary film. Have I watched Borat? Of course. I was probably your age when Borat came out. We'll never see a movie like Borat ever again. I've not watched Dexter. It's too long. Nice, Aaron. Angel. We divide by 2, brev. So 11 minus 3 root 5 over 8 root 5. Just 8. Nice one, Dive. Mazza. It was a times. These are all times. Do you know what? I always used to write times, but because on Instagram, on my Instagram, I have like audiences from around the world, whereas on TikTok it's all UK students. So people all around the world, they tell me off for writing the time. So I'd write like 3 times 4 to the power of x or something, and then they tell me off for writing times in the x, mate. And then I get angry. I try and contain myself. I'm like, shush. Getting told off. I mean, and one of them is, Joe, we write recurring like this. In East Europe, well, I don't even know, maybe in general in Europe, but they write with a bar. And so when I write 0.3 recurring, they bug out. They're like, bro, what is that? One thing I'll never forgive, I don't know if it's again like the whole of Europe. Do you know we write 3.9? I know in Italy they write 3,9, and I'm like, nah, that's just unacceptable. I'm sorry, mate, that's unacceptable. I'm not having that. So I tell people off. When I get angry, it's over. Hey, yo, the comma is so weird. I'm not having it. I'm not having it. You don't want to see me when I'm angry, mate. Yeah, I took my sister's calculator. It's German. And it has that for recurring. Decimal numbers use comma. Yo, Natri, tell your sister to throw that calculator away. I'm not about it, mate. Spain does comma too. It's not looking good. Kira, 3,9 looks like a coordinate. Yeah, how do they write coordinates? They must do this. Nah, that would trigger me. Imagine writing a coordinate like this. Oh, nah, there's no way. I would lose it. I would absolutely lose it. Okay, that's normal, Drags. What are you talking about? That is not normal. That's 9 times 3. Whoa. That could be like 9.3, right? What's your latitude and longitudinal position, mate? Ayo, these guys are bugging. That's a little odd. Always seems reasonable, makes sense. I mean, that's what we say because we're used to it, right? One thing's for sure, though, guys. Now that I'm trying to learn Italian again, English is for sure just the easiest language in the world. There's no easier language than English. Honestly, the English language is so basic, man. So basic. Can you guys multiply out the denominator? Neil got told off. Always getting told off. When am I not getting told off? Neil, try Arabic. Nah, I'm good, bro. The Arabs change the middle of their sentences depending on whether you're female or male, I think. But dude, I'm just not about it. In Italian, the endings change. In Arabic, it changes in the middle, I think. Yeah, it's crazy. You look like the type of guy to have a cat. Well, I do have a cat. Pavel, nice one, dude. If I get an A star and get into my firm, it's all on you. Nah, it's all on you, dude. The hard work was all yours. I just provided a means to learn the maths. My guy. Neil learning Italian. Yeah, I'm just trying to come back to my roots, innit? Here's my cat. That's my cat, Chi-Chi. That was her as a baby, though. She's now 2 years old. Lungang always. So here, what we got? Brush up on the Spanish first. I think apparently Spanish is easier than Italian. I don't know if any of you can speak Italian or Spanish fluently, but apparently Spanish is easier than Italian. So root 7 times root 7 is 7 minus root 3 times root 3 is 3. What do you mean, Katya? Italian's not so bad. Italian's literally the worst language to learn, honestly. Guys, can you expand the numerator term by term? Italian is similar to Latin. I mean, it's one of the Romance languages, right? Rehan, you're half Italian. I'm half Italian as well. Yeah, I struggle. Well, I'm not struggling. I've been learning for like 2.5 months and I'm decent, mate. Might as well learn Mandarin. Trust me. Mandarin's probably easier than Italian. Uno, due, tre. Hey, yo, Russia, you're close, man. Come on, mate. Amina, I see you. Anina, you're also part Italian. Yo, we got all the Italians in the chat. Imparariamo matematica. I'm part Italian. I've learned both. Spanish is more so. Yeah, exactly. That's what I've heard. Sirianch, what's up? Neil thinks he's Fibonacci. So we got. Now here we have to be careful, guys. We have to be careful. 5 root 7 times root 7. Yes, you have to multiply type of number by type of number. So let me try and color code it. So we have 5. Nothing happens with that 5. Times. Then we have root 7 times root 7, which gives us 7. Yeah? Then we have 5 root 7 times root 3. Now that, we're going to have to multiply the surds only. So we have 5. So we have, this is going to be plus, right? Plus 5 root 7 times root 3. You just have 5. Root 7 times root 3 is root 21. Nice. Why am I using dots? Because you guys are cussing me out. I can't win with you guys. Then we have root 3 times root 7 is minus root 3 times root 7 is root 21. And then finally, which color should I use this? Root 3 times root 3 is 3, but it's going to be minus. Okay. 35 minus 3, 32. 5 root 21 minus root 21 is 4 root 21. Over quattro. Quattro. And then we can clearly see that we can divide everything by 4, right? Yeah. Quattro, 32, 8. Root 21. And the denominator is just 1, right? So we don't need that. Pavel, use the 991EX. It is the best calculator, guys. If you can get this calculator here, trust me, it's the best calculator on the market. But they don't exist anymore. So you might have to find them on eBay or something. Or go to CEX. Casio ruined the 991. It did. It very much ruined the calculator, unfortunately. Annie, the CW is the best. No way. There is no way, mate. Tsuranchu, maybe. Alright, so to solve this equation, guys, what are we going to have to do first? I don't know, Ramesa. I don't know why they discontinued it and just made a rubbish one instead. But I robbed mine from school. Kira, you mean this one, right? This big graphical one. It's nice, but it has too much functionality. It's just a bit long. The CG50 is still good though. Yeah, let's expand it. So if you expand this bracket, guys, as is, what does it become? It actually becomes quite nice. The 991 CW, in my opinion, is not better. And Ishan, that Route 36, right? You see that? Zainab, good. Devin, Amina, yep. And then the rest of it as well, right? Angel. Is the 991EX recommended for A-level maths? So, Fassi, the calculator I use on screen is the 991EX, but that's discontinued. So the updated version is the 991CW. If you guys are using the old one, like for GCSE, if it says if the numbers on the top say 8, you can't be using that, yeah? So guys, if your calculator anywhere at the top says 8, do not use it. Yeah, it has limited functionality. Suryanshu, is it free? No. So I have to pay a subscription for it. So you get root 3x plus. Now guys, root 3 times root 12, when you multiply them together, you get root 36, which is just 6. Okay. Then what do we do? Yeah, Taj, you can't use that anymore. Adam, you can't use that anymore. Okay, Ishan, good. So we're going to collect the like terms. Yeah, so we're going to collect the x terms, this positive. Move it over. So we get 2x minus root 3x equals 6. You want to keep as many things positive as possible. And then what do we do once we've done that? Rayan, yes, always homework. For every single session, guys, there's homework. Good. Factorize out the x. And then we're going to divide by the bracket, which would be 6 over 2 minus root 3, right? Times top and bottom by 2 plus root 3. No, BC. Not for A levels. Those are them cheap Sainsbury's calculators. What is the denominator simplified to? Calculator. Four minus 3. Mainly for statistics is why you guys need these calculators. For A-level statistics, you need to have the newer calculators. Okay, you're all getting a 1. So we have 2 times 2, quattro, minus root 3 times root 3 is 3. On the numerator, should you expand? Ishan, do I teach decision maths? I did, but I haven't taught decision maths in like, I don't know what, like 5 years now, I think. 5 years? 4 years? I did it when I did A-level maths as well. Decision maths really easy. Okay, good. So guys, you don't expand it because 6 is a whole number. And that's it. The 4 minus 3 is 1. So x equals... It's not wrong. At this point, it's not wrong to expand it. But it's quite nice like this. Alright, show that root x plus 2 all squared plus this all squared can be written in the form kx plus 1. Alright guys, in the chat, what is root x plus 2 squared? You don't even need to write out twice. Remember the trick I told you? Square the first term, multiply the 2 terms, double it, and then you square the last term. What about the Texas Instruments TI Inspire calculator? Yo, Cap, is that the one that does algebraic manipulation? Probably not worth it. Mazza, is further maths worth it? If you want to do any kind of physics, engineering, maths degree, even if you want to do economics at university, you should consider doing further maths. So, for example, if you guys go on the, I don't know, have you guys heard of LSE before? LSE, London School of Economics. If you want to apply there for economics, you need to, they prefer it if you've done further maths. So, if you haven't, your chances are not as good because a lot of the people who are applying do have further maths. Annie, I do teach further maths, but at the moment I don't have a course for it. Not yet. Not yet. So here, guys, you square the first term. Root x times root x is x. Then you multiply these together is 2 root x. And you double it, 4 root x. Looks like you guys are getting the right answer. And then you square the last term, 4. Okay, nice. Can you guys do the exact same thing for 2 root x minus 1? What does that give you? Neil, is the level 3 FSMQ worth it by OCR? My school has the option. Suranshu, it doesn't make much of a difference. I mean, it prepares you a bit for year 12. But unless you're like gonna 100% get a grade 9, I don't really see a point. If GCSE maths is just clutch right now, I don't see any point. Hopefully, I need to find another maths teacher who can support me and then, like full time. Ari, if you want to be a doctor, you don't need to do further maths. James, what's the trick for not expanding this? You square the first term. Yes, so you square 2 root x. Then you multiply 2 root x with 1 and then double it. Yes, that's the oi bit of the FOIL. Yeah, it's going to give you the same term. And then you just square the last number, number 1. Yeah? Okay, let's see. So I'm seeing 4x minus... Angel, you're close. You just didn't double the middle term. That's all. Yeah? I'll answer some of your questions in a second, guys. So here, you square this. Yeah, you square the 2 is 4. Root x, when you square that, is just x. Yeah, so we squared that. Then you multiply these together. 2 root x times 1 is just 2 root x. And then you double it. When you double 2 root x, it gives you 4 root x. And then you square the last number, positive 1. Yeah? Oops, sorry guys, it's minus 4 root x. Minus. Because it's minus 1, isn't it? So, my bad. Okay, now it did say plus it. So guys, when you add these, what are you left with? When you add these, what are you left with? Kind of used this technique before, right? We added the columns and the like terms. Nice. The 4 root x's cancel. You're left with 5x plus 5, which in my answer, I wanted you to factorize out the 5. And that's it. Yeah, so k is 5 here. Nice, nice, nice. Alrighty then. Oh, that's it. Should we play a Kahoot? Do you guys have questions? Nope. All good, mate. Oh, wait, you guys aren't GCSE. Okay, here it is. Help me, Rhonda. Help me, Rhonda. Help me, Rhonda. Help me, Rhonda. There we go. What options did I do for see Annie? What options did I do for further maths A level? What did I do? So I did the older spec. So we had further pure 1, FP1, FP2, FP3, D1, S2, M2. Those are the options I did. Can't remember what I averaged. In FP2 and in FP1 I got 94%. FP2 I got 100%. FP3 I got 100%. M2 I got 100%. D1 I got 86%, I think. S2 I got 93%, I think. Something like that. But definitely FP2, FP3 and M2 I got 100%. Ishan, they were defined a little bit differently. Oh, wait. I did maths at uni. I don't know. I showed my old A-level students my A-level certificates. They wanted to see. I have them somewhere. I haven't seen the new Deadpool movie. Is stats and mechanics more useful in further maths or interesting? No. Statistics, further maths, FS1 is really boring. What else? FM1? FM1 is probably like just an extension of year 13 mechanics. You do a little bit new stuff like Hooke's law and stuff. Conservation of linear momentum. Work done. The work energy principle. I will watch it eventually. Once I get a bit of time. Alright, what were we saying? We were Lungang. Alright, I'll start in 30 seconds. What does clutch mean? Clutch is like, either you could, I mean, it means a few things. So like when you're playing Call of Duty, if it's a 1v6 and you beat all 6 people, you clutched out. Or clutch, you could say it's easy. Will I go bold, Dara? Wait, why am I going bold? Oh, if you guys get the grade 9s. Alright, let's go. If you guys get the grade 9s, is A-level maths the same as further maths and core maths? Rhonda, if your A-level maths if you're really good at A-level maths, your further maths will be really easy. Simplify this. Boom. I have not seen Suits. I played COD Mobile, that's crazy. I played Call of Duty back when it was actually good, yeah? Modern Warfare 2. Projectile motion looks confusing. Nah, Adam, projectile motion is easy. Alright, most of you got it. So here, guys, you're doing 6 times 3 is 18. Then root 3 times root 3 is 3. So you're doing 18 times 3, which is 54. Can you guys hear? Wait, is it because my speaker's not on? Where's the sound? Is it me or you can't hear the Kahoot music? Wait, you can hear? Yeah, I can't hear it. Nah, Kahoot's bugging out. Yeah, I can't hear it. I bun Kahoot, innit? Oh, I heard that. Do you hear the... Okay, yeah, just Kahoot music's not working. Aaron's on top, though. Let's go. Kahoot's bugging out. Rationalize this. I know this. I hear that. Alright, most of us got it. So your times in Tom by root 2, right? So 3 root 2 over 2. Alright. Let's see. No, what? How, Natty, there's no way you are that quick. How's that possible? How's that possible? Alright, last one. What a banger. Trust me. Solve. Ooh. Alright, I think I'm gonna win this. I'm confident I got this. Here, guys, you can just rearrange. So 9 divided by 16. So you have x squared is 9 over 16. Then you square root. So plus or minus 3/4. Alright, let's see. Oh, I think I won this, you know. Oh. Oh, I'm the king. Let's go. Come on, guys. Get on my level, man. You guys need to step your game up. You need to step your game up. This guy's a sweat. Hey, yo, I even gave you guys a chance. I didn't even answer it straight away. It's time to step your game up, guys. Where's the W's in the chat for me? Neil, what happened yesterday? What happened yesterday? Buddy. Guys, remember there's homework, yeah? There's homework for next lesson, yeah? And yeah, enjoy the rest of your week. Neil, that's crazy. Enjoy the rest of your week, guys. I'll see you. We'll keep playing after every session, don't worry. Never forget yesterday. I don't remember what happened yesterday. I'll see you guys later. Inky Pinky Ponky and Nat. See you guys. Well done today. I'll see you all on Monday. Love you guys as well. Peace out. Peace out. Nice. Oh my god. See you.